everyone, so welcome to my video. For today's video, I'll be sharing with you another amazing program or topic from Java programming. So for today's video, I'll be highlighting the searching algorithm. So when we say searching algorithm, from the name itself, we'll be using this algorithm to search for something, to find for something. And what is that something that I mean? So what I meant about something is the element. So we're using the searching algorithm to find an element or a target value from a data structure, and we're able to do that in two ways. Okay, because our searching algorithm is classified into two categories, and that includes the sequential search and the interval search. Okay, so when we say sequential, from the word itself, sequence. Okay, so we're searching for an element in a way that the list or an array is traversed sequentially. So when we say traverse, it will move from one index to another, right? So the traversal will start from the leftmost. Okay, the traversal will start from the leftmost part of our array, okay, until we find rather the target value. Okay, so every element is checked when we say sequential search. Okay, every element is checked until we find the target value. So an example of a sequential search is the linear search. Okay, so another is the interval search. So when we say interval search, it is another searching algorithm. Okay, so in interval search, it is specifically designed to search for a sorted data structure. So when we say sorted, the elements are sorted in a data structure, in a data set. Okay, so when we say it's sorted, the elements are placed or positioned in a way that they are not random. Okay, they are not randomly positioned or placed. Okay, because when we use, let's say, the interval search, okay, when we are searching for a target value in an unsorted data structure, our interval search will not perform well. Okay, it has its rule, of course. It is one of its rule. Okay, so we're only using our binary search in a sorted data structure, in a structure that is either ascending, that has either ascending or descending elements. For instance, the 1 2 3 4 5, it is an ascending elements, right? When we say 5 4 3 2 1, it is descending. Okay, those are an example of a sorted data structure. Okay, so those are a great example of our sorted data structure. So in finding a target value in that data structure with those elements, with those sorted elements, then we will be using the binary search. Okay, the interval search. So a binary search is an example of an interval search. Okay, the good thing about the interval search, it is more efficient than the let's say the sequential search, because the sequential search, it will start from the leftmost, right? Whereas when we say interval search, it will start from, the middle, okay, and it will divide the space, into half. It will repeatedly divide the space into half. And when the middle, okay, so it is in binary search, that when, the middle item is greater than the target value, then we will proceed to the left, or to the lower part of our array, okay, with a formula of left equals mid plus 1. So when the, let's say, our mid is less than our, target value, then we will proceed to the right, okay, to the upper part of our array, which is with a formula of right equals, or upper equals, or high equals mid minus 1. Okay, so I just included those so that okay, because I believe that those are important, okay, because those will be used in our program, in our program that we'll be creating today. Okay, so let us talk about first the menu oriented program. So I'll be doing, okay, in this video is I'll be letting you watch me create a menu oriented program. Okay, you can skip the part, but at least I can show you that I am creating, while I am creating the menu oriented program. Afterwards, I'll be like sharing or discussing to you how did I come up with this output, or why are this the methods that, why are this the operations that I use for this program, right? So I'll be discussing that later on, after you watch me create a menu oriented program. Okay, don't worry, it will be in time lapse, it will be in fast forward rather, okay, so don't worry. So before you proceed, before you watch me create a menu oriented program, okay, so let us know first what is a menu oriented program. So when we say menu oriented program, it is a programming approach that displays let's say a set of operations that the code can perform. It will display a set of operations that the code can perform or execute, and the user will be asked to choose from one of those. Okay, so we'll be providing a menu of options to our user, okay, for them to use, or for her or him to use. No, not use, for him or her to choose rather. Okay, so we'll be giving a menu of options that the user can choose from. Okay, and those options, are the menu of options that I'll be giving, includes the linear search and the binary search, because of what we're going to do is, okay, so I'll be showing to you. We have here this one. We have here the objectives of creating our menu oriented program using switch statement for the decision process. So first, the program must ask the user to input the size of the array. Secondly, the user will insert elements to the array. The number of inputs is dependent to the prior inputted array size. Thirdly, the user will input a search value of which the system will search in the values inserted in step 2. After that, the user will select what searching technique to be used to execute the searching process. Okay, that searching technique is either the linear search or the binary search. Take note of the sequence of the element, whether it is sorted or not. This is very important factor used to identify which best technique to be used for the process. Then the program must print the index or location of the search value, otherwise print not found. Okay, so this is the objective of creating our menu oriented program using switch statement for the decision process. Okay, for the decision process of our, since we are letting our user decide, what we are going to use is the switch statement. Okay, so in our switch statement we are using break right, unlike our if statement, unlike our if else statement. So I think it is much advantageous to use switch statement. Okay, just for me. Okay, so here is a sample output. I'll just be showing to you. Okay, so the output should be like this, at least like this. Enter size of array, enter 5 element, enter elements, enter value to be searched. Okay, this is the target value. Choose your desired searching technique, diba? It's either the binary search or the however, there is a note that binary search is only applicable to sorted array. So we wanted to ask the user if the array is sorted. We wanted to know if the array is sorted, because if the array is not sorted, then the user should not be choosing the binary search. Okay, the user should be choosing the linear search, because the binary search is only for a data structure that has sorted elements, right? So that's it. And there will be showing a menu of option which only has 2 options, the linear search and the binary search. Enter your choice. Binary search is not applicable because the array is unsorted. This will happen if this will be printed if the user is stubborn. When we say stubborn, when the user is hard-headed. Okay, we have already put a note that the binary search is only applicable to sorted array if the array is sorted, and then if she entered no because the array is unsorted, then still he or she chose and still choose rather the B or the binary search, even though she knows or he knows that the array is unsorted, then it will print out binary search is not applicable because the array is unsorted. Okay, but if he or she chose the A or the linear search, then this will be the one. These are the following output elements in the array, and then the value that you search for is index or location of the array. Okay, then this will be the last. Thank you for using this program. Okay, this should be at least our output. Okay, so now let us proceed. Okay, so let's go on. Watch me create this program. Okay, so welcome back. Okay, so you have just seen me creating a menu-oriented program using switch statement for decision process. Okay, so here are our code. Okay, here are our written code. Okay, as you can see, here is our program. We are already done creating our program. So the next thing that we will do now is I will be rather like discussing to you, okay, of why are this the methods or operations that I use for this program, of what code is this, of why is the output like this, and so on. Okay, so sit back and relax, enjoy listening to my discussion. So here it is. Let us start with the code first. Let's start explaining the code first. So in our code we have here, so we have here a package. Okay, the package that we're using, we named our package into menu oriented program. And then next code is that we import a java.utility package. Okay, so we imported the whole package of utility, not exactly the class, not the single class only, not the scanner only, not the array only, because we'll be using array and scanner, or even if we're not using one or more, right, it will still work, okay, if we import the whole package. Okay, when there is an asterisk there, meaning to say we just imported the whole utility package, or the whole package, not only in utility. For example, we have we are importing another package and there is an asterisk, meaning to say we are importing the whole package. If for example the asterisk is this is not asterisk but a scanner, or let's say an array, then we're only importing a single class. So we are only importing, for example, a scanner class. Okay, for example, we're putting here scanner. Okay, we're only importing the class scanner that's in the utility package, because our scanner class belongs to utility package. Utility is a package, scanner is a class, and our package is like a folder. It holds it also it's just like a folder. Okay, I can compare it, or I can let's say relate it to a folder. It holds classes, related classes. Okay, so that's it, utility. Okay, so we change the asterisk into scanner. So from importing the whole package, we just imported only a single class, scanner, that belongs to a utility package. Okay, so next is we created a main class, menu oriented program. Okay, we created a public class. Okay, so when the access modifier of our class is public, meaning to say our class is the main class, meaning to say our menu oriented program is the main class. Okay, I would like to add that if we can only put public access modifier to our class if that class is named it has the same rather it has the same name of the file. The name of our file is menu-oriented program. So that is why we can put public here. It is our main class. Okay, we have a public class menu-oriented program. So we named our class and our file into menu-oriented program. It's because the one that we'll be creating is a menu-oriented program. Makes sense. Very understandable. It doesn't need to be explained already. Okay, as much as possible we wanted to put names in our program, or we wanted to put labels, or let's say variables, attributes, and so on, that is meaningful. Okay, so next is I just put a I just placed a comment before the the method here. I just placed a comment that method for linear search, meaning to say this indicates that this is a method for linear search. Okay, so when we say linear search, again, it is an example of a searching algorithm, sequential. Okay, so this is so we just defined a linear search method. Okay, when we say method, it will perform a certain operation once it is called. So once we call this method, which is linear search, it will perform a certain operation once we call it or invoke it in our main method. Okay, so now let us find out what operations thus this method will perform. So of course our main method has an access modifier of public and a non-access modifier static. Okay, so we put an access modifier of public in our main method linear search so that it can be accessed in any classes. Okay, and it is in static, okay, to indicate, right, that it belongs to our class menu oriented program. Aside from that, we no longer need to create an object of a class menu oriented program just to let's say access this method or just to invoke this. We can directly call this method without creating an instance of a class menu oriented program because it is static. Okay, so our method is in integer data type. Okay, it is not in void, so meaning to say we will have to return an integer data type or a value in integer data type. Okay, we'll have to return an integer data type to our linear search method because we have specified it when in an integer data type method. So we of course name it into linear search so that it is identifiable, right? So that we can identify that this is a method for linear search, right? So in our linear search method, we have a parameter of int array and an int value. Okay, we have two parameters. So when we call this method in our main method, okay, it will return an array and a value. Excuse me. It will accept rather an array and a value. So why are we why do we have this int array parameter? So we have this so that we can use the array. We can use the array. So this array, has already been defined in our main method. Okay, here it is. For us to be able to use this array, we'll have to make it a parameter. Okay, we'll be using this. Okay, for us to be able to use it, we'll have to make it into a parameter. Okay, and of course this int value, this is the target value. Okay, this is the target value. This is the one that we'll be comparing to every element of our array, just so you know. So next is we created a variable of size. Okay, variable of size. No, we created a variable size in integer data type. So we created obviously from its word size. So we will be storing here the size of our array. Okay, which is the array.length. Okay, so we have already stored the length or the size of our array in our variable size. Next is I just put a comment here: traverse starting from the leftmost of the array through this for loop. Through this for loop. Okay, this will be used to traverse. This will traverse rather starting from the leftmost of the array till the last. Okay, till the last index of our array. But it will stop. It will be checked every element of our array will be checked through this if statement. Okay, so here it is. For int I equals 0, I should be less than the size, I increment. Since 0 is less than so on, right? Then it will start checking from the traversal will start from the index 0. Okay, so we will start checking from the index 0. Okay, until the last size. However, we'll check if the array I, which is if the element, okay, is equal to value, which is the target value. Okay, then we will have to return its index. If the element is equal to value, this is when we read this, it is read like this: if the element is equal to value or target value, then we will return the index of that element that is equal to value. But if none of the elements of the array have matched the target value or the value, then our method linear search will return -1. Okay, there's a comment. There is a comment here. I put a comment here. Will return -1 if value doesn't match with any of the element. Okay. So next method is the binary search. Okay, another algorithm, searching algorithm, right? That is it is an example of our interval search. So of course it still has a public access modifier, meaning to say it is accessible in any other classes. It also has a static non-access modifier. As I've said, when it has an access modifier static, meaning to say we no longer have to create an instance of a class menu-oriented program for us to be able to access or for us to be able to use this in our main method. Okay, So it has a data type integer, so we have to return a a value in integer type in this method, okay, because it is not in void. So we'll have to return an integer data type to this method. And in this method binary search, we have a parameter int array and also int value, the same with our linear search. So for us, because we'll be using the array, okay, the values of our array, we'll be using this in this method. That is why we use it as a parameter. We also have the int value as a parameter. This will accept a value, which is the target value. So next is we created a variable lower, okay, an integer type. So with an initial value of 0. So 0 because 0 is the leftmost, right? The leftmost part of our array. It is the lower, right? It is in the left. While the upper, or let's say in the right, is the array dot length. Array dot length. Okay, I forgot to put, I think this should be array dot length minus 1. Okay, array dot length minus 1, because if it is not in, if we don't put minus 1 there, it will only create an error. Okay, it will, let's say, exceed, right? It will create an error. So let's put a minus 1 there, because the last index of our, let's say, of our array is minus 1 of our length, right? So we have initialized the values of this lower and upper variables. Excuse me. Now we will proceed to our while loop. So what is the use of this while loop? Okay, this while loop, okay, is as much as possible, this will always start in the middle, right? Because our method will repeatedly divide the interval, let's space of our array into 2, because in that way it is the most of it is much efficient than the linear, okay, the linear way. So we have here while lower should be less than equal the upper. Okay, if the lower is not less than, when it is already greater than the upper, then the loop will terminate, right? So int mid equals, okay, int mid equals lower plus upper minus lower divided by 2. If the lower is less than or equal upper, then this block of code will be performed. This following block of code will be performed. So this is an algorithm. Excuse me. Int mid is equals to lower plus upper minus lower. Of course, this will be the first one which will be performed, and then next this, and then lastly this one, right? Then after that, after we're able to identify the middle item of our array, we will now check if the array, which is the middle item of our array, is equal to value. If the middle element of our array is equal to the target value, then we will return the index of that middle element. Okay, return mid. Else if else if the mid is not equal to the target value, then we will have to check if that element is less than the value, because if it is less than the value, then we will proceed to the upper part of our array, okay, or to our right. Okay, I know I will proceed to our lower rather, so mid plus 1. Okay, else if the array mid or the element is greater than the value, excuse me, we'll proceed to the upper. Excuse me. So if none of the following elements match the target value or this value, then our method will return -1. Okay, this will return -1 to our method. Okay, so that's it. So we are already done defining our two methods or our two operations. These two operations are useful in our program. We defined these two operations in our program, these two methods, because we will be calling this 2. Okay, we'll be calling this 2 and we'll be using them in our switch statement. Okay, once the user chose the linear search, which is the A, then this method will be declared, or this method will be invoked, and once it is invoked, it will perform a certain operation, which is it will return an index, the index of the element that is equal to the target value, else it will return -1 if value does not match with any of the elements. If the user chose the binary search, then it will, or the B, it will, our method will be invoked, or it will be called, and it will perform a certain operation, and that operation is it will, compare the target value from the middle part of our array. Okay, it will keep dividing the space into 2 until the value is already matched to the element of the array, or till the interval is empty. If the interval is empty and nothing, or none of the elements have matched the, let's say, the target value, then our method will return -1, right? So that's it. Now let us proceed to our main method. So in our main method, of course, when we say main method, it is a method in which where we put codes that are to be executed. Okay, it is where our compiler starts reading. That is why this is important. Okay, if we don't have this, then we can't see anything on our console. Okay, because these are the codes, this is where the codes are put that are to be executed. If we wanted to use these methods, then we will have to mention, or we will have to invoke these methods, or to call these methods in our main method, public static void main string args. So in our public static void main string args, we created an instance of our scanner class. Okay, and our object of our scanner is input. Of course, our scanner will be used to accept, it will read, the user's input. It will read the user's input from the word scan. Okay, so it has methods, of course, because it is a class. It has methods that will perform operation for our scanner class. Okay, so its source is system.in. So our objects is input. We will keep referring to this when we are using the scanner class methods. Okay, so we just declared a system.out.println method just to create a space, So next is we will, through this method, through this declaration, this will print, or this will prompt the user to enter size of array. Okay, this will signify to our user to enter size of array, and whatever the user will enter, whatever size our user will enter, then it will be stored in our size variable, and it is read by our scanner using the method nextInt. Okay, so for instance, for example, our user entered the size 5. So 5 will be stored in our size variable, and that will be the size of what? That will be the size of our our array. Okay, that will be assigned to the size of our array. So this is what we call the creation of array creation, or creation of array. Okay, either of the two. Okay, so we just created a array with a size of 5, for instance. As I've said, for instance, or as an example, the user just entered 5, and the 5 is stored in our size variable. So meaning to say, the size of our array will be 5. 5 is the size of our array. Okay, so next is we printed a system.out.println enter size elements. So before that, I would like to add this for space purposes. So enter size elements. When we say enter size elements, this will prompt the user, for instance, enter 5 elements. As I've said, for example, that the user just entered a size of 5 for our array, and it has been stored in our size variable, and that will be already the size of our array. And now we will prompt the user to enter 5 elements. So the user will now enter 5 elements, and that will be read through this for loop. Okay, so the first value that the user entered will be read one by one through traversal. Okay, through traversing, of course, and they are stored in every element of our array. So the first value that the user will be entered will be stored in the array 0, which is the index 0, the first element. The next will be stored in array 1, which is the second element, right? So they are read by the scanner using the method next int, and they are stored in every indices of our element, of our array rather. So next is we created another space, and then we prompt again our user to enter value to be searched, meaning to say we wanted the user to enter the target value he or she wanted for us, or for our program rather, to search or to look for or to find, right? Because we are talking about searching here, that is why there is enter value to be searched. We are searching for something, we're searching for an integer value, an element. So now our the value that will be entered by the user, that is to be searched, will be stored in our target value variable. Okay, it will be stored in our variable target value. Okay, so it is read through the next int method of our scanner. Okay, so for instance, for example, the user have entered 5 elements like 1 2 3 4 5, and she wanted to to search for 3, so that will be the target value, right? So now we have printed a space again, and then we printed this on our console, which is choose your desired searching technique. So this will indicate to the user to choose your desired searching technique. So what techniques? Linear search and the binary search. So there is a note here that take note that binary search is only applicable to sorted array. At least we told our user in advance that our binary search is only applicable to sorted array. So if ever she have entered elements that are not sorted, then she will have to put here n or no. Is the array sorted? Of course no. If the array is not sorted, then she should not be choosing the binary search. That's it. So it is the choice of the user which either y or n, or yes or no, will be read by this, and it will be stored to answer, which is a variable in character data type. Okay, through this next char at index 0, which is the first character, okay, will read the first character. Okay, if the user will enter yes, as long as there is a y in the first, then it will be stored in the answer. So next is we just printed another space, and then we will print a menu, okay, which is the menu: A, linear search; B, binary search. This is our menu. So next we created another space, and then we will prompt to the user through this statement to enter your choice. Enter your choice, meaning to say, to enter the user should be entering his or her choice. Either she wanted the linear search or the binary search. Okay, it's either she will her choice is either A or B. A for linear search, B for binary search. and whatever choice she have or he have made will be stored in our choice option variable in character data type. Okay, and then we created a variable value and result in integer data type. They will be used later on. I will just explain the use of these two once they are already used. Okay, we just declared this too. So next is we will now proceed to our switch statement. So whatever choice the user will enter will be checked. Whatever matches to the cases. Okay, the case that matches the choice, its block of code will be the one that will be performed or executed. So for instance, we have the switch choice option. If the choice option of the choice of the user is A, then this case A will be performed, then break, meaning to say it will no longer proceed to case B because our just declared a break. It will directly terminate because it has declared a break. If it without a break, it will proceed to case B, just like a loop, and we don't want that to happen. Okay, so we have here the case A. In our case A, if the user have entered or have chosen the A, which is the linear search, this block of code will be performed. First, it will print out the elements in the array. Okay, it will print out the elements in the array. And we're able to give the elements of the array through the for each loop, or we can also use the for loop actually. So we just use the for each loop that is specially used for arrays, the elements of our arrays. So int E, this is for our element, and then the array is the name of our array, and then we printed the E. In that way, the elements in the array will already be printed on our console. Then now we have declared our value, right? The one that we have declared. So we just stored our the target value of our value variable. So we stored the target value to our value variable. Okay, value that we put in our linear search and also binary search as parameter. So meaning to say, this target value will be accepted to either linear search or binary search. Okay, that's it. So now we have the result. So we stored in our variable result the linear search array value. So in our result, we invoked or called the method linear search. In that way, this linear search method will perform an operation. Okay, so array value. Okay, this array is the array, our array, whereas this value is this one, which is the target value. This will be accepted by our method. So since this is called, we will go to our linear search method. Okay, we will go there, and these operations will be performed. So for instance, the user have entered let's say 5. Okay, for instance, the target value is 5. Okay, I know I have okay, I'm sorry, I just said earlier that the target value is 3, right? And we have 1 2 3 4 5 elements. Okay, so we have the 5 target, we have the 3 target value, and that will be accepted by our method linear search. So we'll go to our method linear search. It will accept the 5 here. Okay, and this will accept the array. Now we're in size, the size of our array, and then we will traverse from the leftmost of our array, so from 0. So 0, for instance, we have the 1, right? The value over 0 is 1. So since 1 is not equal to our value, which is 3, it will not return the index. So we'll proceed increment. So we have the 1. So from 0 it will become to 1. So 1 is less than the size, which is 4, which is 5, right? So what will happen is the value of our index 1 is 2, and 2 is not equal to our value, which is 3, so it will not return the index. So increment, it will become to 2. So 2 is less than the size, which is 4. So our index 4 will be checked. The index 4 it has a value of the index 2 rather, index 4. Index 2 rather has a value of 3, and 3 is equal to value, right? Value is, our target value is 3. So since they have the same value, then the element, or no not element, the index of our element 3, right, which is the index 2, will be returned. So index 2 will be returned to our, it will be returned here in our result. So the value of our result now is 2. Okay, so after that, we will check through this if statement if the result is equal to -1. Since the result is, because if it is in, -1, if the result is into -1, then this will be printed out in our console. Element is not present in array. However, our result is not equal to -1 but 2, right? The value of our result is 2 because, our linear search method just, returned index 1, index 2. So this will be the block of code of our else will be the one that will be performed. So the value that you search, this will be printed on screen. The value that you search for is in index or location 2 of the array, because 3 is in location or in index 2, right? Then break, automatically break. It will not proceed to case B, only case A. We are done performing the operations of our case A, so that is why we took a break. Yes. However, okay, there is a however there. However, if the user, have chosen the B, which is the binary search, if the user have entered, like chose, for example, what if the user entered here a B, okay, then this will be, the block of code of this case will be performed, right? So the first block of code is that we will have to check if the answer is equal to n or in small letter or in lowercase or in uppercase, because if the answer is equal to n, meaning to say, Okay, right here and here, right? If the answer is n, meaning to say the array is not sorted. And when the array, excuse me, and when the array is not sorted, meaning to say binary cannot perform, the operation. It cannot, binary search is not applicable because the array is unsorted. As I've said, binary is only applicable, or it will only perform well or function well when the data structure's elements are sorted. It's either in ascending or descending, as long as it is sorted. However, for example, because the user is stubborn or hard-headed and she still choose the B even though she have already like answered into N or no, this will be printed to the console, which is the binary search is not applicable because the array is unsorted. Okay, so now we will now proceed to our we will now proceed to, if the answer is not N, if it is yes, if our data structure is sorted, then we'll proceed here, actually here. So we just stored our value, the target value, for example 3, as I've said, just like here in our case A, and then in our result variable we just invoke or called our method binary search. Okay, so this binary search will store something to the result. So since it is called or invoked, we will now go to binary search. But before we do that, let us put an else first, I think. Okay, let us adjust this first because I think okay, that's it. So we've already we have adjusted something else. If the answer is yes, then this will be performed, right? So value is equal to target value, and then since it is called, we'll go to our binary search method. So in our binary search method, we have a parameter int array, so we'll be able to use the array and the values of our array and also the int value. Okay, the int value is the target value. Okay, we have stored something there, which is the target value. So the target value, for example, is 3, right? So 1, 2, 3, 4, 5, right? So the 3 is the target value, as I've said. So now we will store in our lower variable the 0, and then the upper is the array.length -1. Okay, so while lower should be less than equal to upper, since lower, which is 0, is less than equal to, since lower, which is 0, is less than equal to let's say 4, right? So this will be performed. So mid is equals to let's say excuse me. So our mid is let's say, so our lower is 0 and then plus, so upper is 4, so 4 minus our lower is 0 and then divided by 2, so equals 4 minus 0 is 0, 0 divided by 2, 4 minus 0 is 4 rather, 4 divided by 2 is equal to 2, and 2 plus 0 is equals to 2, right? So 4 minus 0 is equals to 4, 4 divided by 2 is equals to 2, 2 plus 0 is equals to 2, so our mid is index 2. Okay, so index 2 is our mid. Okay, so our index 2 is 0, 1, 2, so 1, 2, 3, so 3 is our mid, right? So if now after finding the mid item of our array, we will now check it, if it is equal to value or if it is less than the value or greater than the value. If the array mid or the element is equal to value, the element of our index 2 is equal to value, return its index. Okay, since our index 2 is 3 and our value of our target value is 3, we need to say they're equal, right? 3 is equals to 3. So now we will return the index 2. Okay, we will return the index 2. Okay, so it will return index 2 here. Okay, the result is index 2. So now we will check, we will check the result, which is 2. If result is equal to -1, which is not, result is not equal to -1 but 2, so this will not be printed. Else, this will be the one that will be printed. The value that you search for is an index or location 2, which is 2. The result is 2, right? Of the array. And then break. Okay, so that's it. Okay, that's actually how it works. Okay, those are the explanation of the every code of our program. Okay, so of course it's not the end, right? After knowing the value that you search for is index or location of the array, you'll print a space and then here is a closing remarks. I think just to to thank the user for using this program. So just printed on the console the final the last message is thank you for using this program. Okay, and then we closed our input, we close our scanner class. Okay, so that's it. That's the explanation of the every code of our program. I hope you guys have actually learned a lot with my explanation. Now that I've already explained the every code of this program, I would like to run this program, right? To run the code of this program. So let's click the F6 since we're using let's say the NetBeans. Okay, let's run the program. Okay, so now that we've already run the program, let's now enter the size. Okay, as you can see here, enter the size of array. So the size that we wanted, for example, is 5, just like what we said earlier. We wanted to do it. So next is enter 5 elements. So enter 5 elements. For example, just like what we said earlier. So 1, 2, 3, 4, 5. So enter value to be searched. So the value that we wanted to search is 3, just like what we said earlier. We wanted to demonstrate it, not only speak it, right? Let's demonstrate it so that you guys will not only imagine, you guys can also see the output. So enter value to be searched. Now choose your desired searching technique. Please take note that the binary search is only applicable to sorted array. Is the array sorted? Since our elements of array is in ascending, it is sorted, so let's put y. Okay, so now we are given a menu. Okay, a menu in which we will choose, right, an option. So either A, linear search, or B, binary search. Since our we wanted to make use the binary search because it is only used for a sorted let's say data structure or elements of our array, then we would choose the binary search. Enter choice B. So now we have the value that you search excuse me, the value that you search for is in index or location 2 of the array, which is correct. Our 3 is in location 2 or index 2 because our 1 is 0, our 2 is 1, our 3 is 2, right? Thank you for using this program. Here is the whole output if you wanted to see. Take a look at that. We have right output, right? We have the same output as I have mentioned earlier as an example. Now we will run another example. Okay, we will run again our program. We'll make use of the A also. Okay, so now we'll have to enter the size of array here. The one that I highlighted. So the size of array that we wanted is, for example, 7. So now enter 7 elements because the size of array that we chose is 7. That's why enter 7 elements. So enter 7 elements. We'll start. We'll randomly put numbers 8, 2, 4, 5, 9, 12, and 3. So enter value to be searched. So the value that we wanted to search from these elements is 9. Okay, 9. So now we will answer the question. Choose your desired searching technique. Please take note that the binary search is only applicable to sorted array. Is the array sorted? As you can see, 8, 2, 4, 5, 9, 11, 12, 23, they are not sorted. They are placed or positioned randomly. So meaning to say they are not sorted elements. So what we wanted to do is we'll put N, which means no, it is not a sorted array. So enter. We're now given a menu of options. Okay, we're now given a menu of options, and we'll have to choose from these two. So now we'll choose, for example, the binary. Okay, let's pretend that we are a stubborn user. Okay, we already know that our array is not sorted, but we still wanted to use the binary search. Let's see what will be the reaction of our program. Our program will be angry, char. No, it will print binary search is not applicable because the array is unsorted, right? So our program is just, doing what is the right thing. Okay, it is doing what is the right thing. So now let us proceed to another. Okay, so wait, let us pause first our video because our lighting is, it just turned off. Okay, it went dark here. Let's pause. Let's continue. Okay, my lighting just went off. Yes, it went, it shut down. So let us continue. Let us run another program. Okay. So now we will enter size of array. For instance, the size we wanted the size we wanted is, for example, 10. Let's size up. Right. So enter 10 elements. Random, still random. 4, 3, 6, 8, 9, 10, 3, 5, 6. So now we have already 10 elements. Now our program wanted us to enter value to be searched. So we wanted to search for 56. Choose your desired searching technique. Please take note of the binary. So our array is not sorted, obviously, so we will put no. So now let us choose the linear search. Let's see what will happen. So because we chose the linear search, what happened is, it just printed elements in the array are. Okay, just like our objectives. Okay, just like this. Okay, elements in the array are. So the value that you search for is in index location 9 of the array. So let's see if the 56 is really at the location 9 of the array. So we have 10. We have size 10, right? So 10 minus 1 is equals to 9. So indeed, it is in index or location 9 of the array. So indeed, thank you for using this program. Very thankful also. So that would be all, I think. Or we wanted, let's do another example. I think that would be all. Or let's do another example. Okay, let's do another example. Let's do another example. Okay. Another example would be, let's put just 4. So enter 4 elements. 1, 2, 4, 7. So it is still sorted, right? Ascending. So enter value to be searched. We wanted to search for, we wanted to put a number that is not available in our elements. Let's see what will happen. So for example, we'll put 3. Choose your desired technique. Please take note that search is only applicable to sorted array. Is the array sorted? Yes. Let's choose B. Element is not present in array. Indeed, 3 is not present in 1, 2, 4, 7 elements. So our program really did well. Okay, so that concludes that our program, that our objective rather for our menu oriented program using switch statement for decision process was successfully accomplished. Right, we did a great job in creating this program. Okay, so you watching me creating a menu oriented program is just worth it because we did a great job. Okay, so that would be all for, I think, for today's video. I hope you guys have learned a lot for today's video. Yes, I just really hope you guys have learned a lot. I hope you guys have learned a lot for today's video. Again, menu-oriented program is a programming approach that displays a set of operations that the code can operate and ask the user to, let's say, to choose from one of them. Okay, so what we did in our program, we asked the user to choose either the linear search or the binary search. Okay, also remember the searching algorithm is for searching an element from the data set or from a data structure or from the array, right? Okay, and we're able to do that through linear search and the binary search. I hope you guys have learned a lot for this video. Thank you for watching, and I see you again soon. Thank you.